Vectors. How do you do vectors? So vector is an arrow that describes direction and magnitude. So direction meaning how far we've turned, magnitude meaning how far we've gone. So here we have a vector v going 6 miles, and we've gone 48 degrees. Now, it's important to know that vectors we always start right here and turn counterclockwise, okay? Always turn counterclockwise. Why? I don't know. Some person said start there, and so that's where we start. So we always start right here on the x-axis, start going through the first quadrant. So we're going to break this vector down into its component form, okay? We use these sharp brackets. And then we have the how far in the x direction and how far in the y direction to do this. So essentially though, what I have is a right triangle with a hypotenuse of 6. So if I want to find this side right here, how far I've gone in the x direction, I'm going to set up my proportion. So this is the adjacent. That's the hypotenuse. So, of course, we got to use SOHCAHTOA. So the adjacent side right here, the hypotenuse, when you use cosine, the cosine of 48 is equal to x over 6. So now what I'm going to do is I'm going to take both sides, I'm going to multiply by 6. So I just got to figure out the x right there. Multiply both sides by 6. So the x component is going to be equal to 6 times the cosine of 48. And I'm going to get out my calculator here. 6, make sure it's in degrees, of course. 6 times the cosine of 48. And so how far in the x direction is it? 4.01. So 4.01 in the x direction. This side right here, the y component, how far up? Well, let's see here. That's the opposite. That's the hypotenuse. So opposite hypotenuse, I'm going to use sine right there. So the sine of 48 is equal to y over 6. And then I'm going to multiply both sides by 6 to get the y by itself. Oh, sorry. So y is equal to 6 times the sine of 48, 4.45. And let's call it 4.6. And so now I've got my y coordinate. So this tells me how far I've gone in the x direction and how far I would go in the y direction. Now, the interesting part about this is to get the x right here, I had to use cosine and just multiply both sides by 6. To get the y part right here, I had to multiply both sides by 6. And I use the sine function. Let's see what happens up here. So I'm going all the way over here this time. So to find out how far I'm going in the in the x direction, right here, I've got 220 degrees all the way over here. Now I could look at this and say, well, there's 180 right there. So that means this has got to be 40, that's 180 to there, 40 to there. And I could do the whole thing that way. So I could to find the x coordinate, the adjacent over, that's the adjacent side. That's the hypotenuse. So I'm going to use cosine again. Ooh, cosine to find the x coordinate. Cosine of 40 is equal to x over the hypotenuse, which is 15. So multiply both sides by 15. And And x is going to be, get my calculator ready again. The cosine of 40, close those parentheses, times 15, and I get 11.49. Now, something to keep in mind, though, this is going backwards. We're not going in the positive direction. We're going in the negative direction. So it's actually negative 11.49. What would happen if we did 220 degrees? Let's try that. 220 degrees. Holy cow, do you see that? If I use 220 degrees, it makes it negative. That's fantastic. So it's negative 11.49. So I can use the 40, or I can do 15 times the cosine of 220 is x. I can just go ahead and use that angle. Let's see if it works for the y-coordinate as well. So, got to find the y-coordinate. Let's see here, over to here. So the y-coordinate is going to be negative. Okay. So that's the opposite from the angle. That's the hypotenuse. So we got to use sine again. That actually is important. Sine of 40 is equal to y over 15. So multiply both sides by 15. And get the calculator going again. So I'm going to do 15 times the sine of 40, 9.64. What if we change that to 220? Negative 9.64. That's fantastic. So we really just have to do, if we want the y-coordinate, we always have to use sine of the angle times the hypotenuse, or the radius, I guess you could think of it as. So I could just do 15 times the sine of 220. And that will give me negative 9.64. Brilliant. Okay, coming right down here. So this one is negative 50 degrees, or positive 310. They're the same thing, really. 310 degrees around or 50 degrees backwards. Same thing. Here I'm using newtons, or how much force is being applied to something. It doesn't always have to be distance, and we'll see that later. If you don't like newtons, you could think of this as nanometers if that makes you feel better. But I'm going to go ahead and say newtons, because vectors apply to lots of things. All right, so we've learned that to find the x-coordinate, really I just have to do the radius, 25, times the cosine of the angle, 310 degrees. Let's also check it with negative 50. See if we get the same thing. So, get the calculator ready here. 25 times the cosine of negative 50. So that's 16.06. Or 16.07 if you want to round. What if we did 310? 16.06. Fantastic. Round it to 07. There we go. And that makes sense. The x-coordinate is positive because we're still going in the positive direction here. The y-coordinate should be negative, so let's check it. So instead of cosine, let's do 25 times the sine of negative 50, so negative 19.15, or what if we did 310? negative 19.15. Same thing no matter how we do it. So I've got negative 19 newtons going down and 16 newtons going sideways. Okay, there you have it, vectors. So to break it up, you're going to do to put it in component form, we're going to take this is called the magnitude times the cosine, sorry about that, magnitude times the cosine of the angle is the x-coordinate. The magnitude times the sine of the angle is the y component. I said coordinate, but it should be component right there. Magnitude times the cosine of the angle is the x component. Magnitude times the sine of the angle is the y component. Or you can think of this as the hypotenuse. That's the big thing you got to take away from this right there. How to change vectors into component form. Thanks for watching.